having the knowledge about how a polynomial behaves near its zeros, we're wondering, okay, what about everything else? What happens in its long-term behavior as we get further away from the zeros, further away from the origin, okay? And the basic understanding of polynomials is that eventually, as x gets really large positively or negatively, so as it approaches positive infinity or negative infinity, and again, in terms of mathematics, how we communicate this is with the notation x to infinity or minus infinity. This is called limit notation, okay? And when you get to calculus, if you go that far, there will be some extra notation that we include with limits, but for now, we'll call this limit notation. Okay, but this is saying as x goes to positive infinity, so as we go to the right on the graph, or as x goes to the negative infinity to the left on the graph, every polynomial function either rises or falls without bound. So again, the other part of limit notation would be saying as x changes, what happens to y? So y is either going to rise in the case of f of x approaching positive infinity, or fall as f of x goes to minus infinity. Okay, and so how do we know which one it is? It depends on the leading term exclusively. Okay, and in the leading term, there is the degree and the leading coefficient, both of which end up being super important. Okay, and so to analyze the leading term, there is this leading term test that we can do. So it is rather long, so have your patient pants on. So if we have a polynomial function, we have 4 different cases to consider. The first case is when the degree of n is odd, okay? And when a of n is positive. So let's think about, so n is odd. Let's say that, y equals x cubed, and we're saying that this is positive x cubed. Mental picture that we should have, we know the graph of a cubic looks something like this, okay? And so in this case, right, it says it's, let's see, it falls to the left and rises to the right, okay? So this notation here we haven't seen before. This I'm going to call arrow notation. Okay, and what this is really meaning to say is, and then this is more limit notation, that as x goes to the left, okay, as x goes to negative infinity, so we're going this direction in the graph, it's falling vertically. So that's why we have the arrow down and to the left. As we go to the right, as x goes to positive infinity, then it rises. So that's why it's going kind of northeast, okay, in our arrow notation. So that's if an is positive. So again, this is an, and then this is n, okay? Next case is if we have an as negative, so just negative x cubed. Mental picture of this, so this would be a vertical reflection of the cubic function. Okay, something like that. And so as we go to the left, right, it's rising. And as we go to the right, it is falling. And again, arrow notation, limit notation needed to be fluent in both. Okay, now we're going to switch gears and talk about even. Okay, our base example is something like a parabola. X squared, the degree is 2, even. And in this first case, we're saying positive. Mental picture is something like this. Okay, so as we go to the left, it's rising. As we go to the right, it's rising. So that's why we have up and up arrows. Okay, and for the arrow notation, and then in limit notation, we're saying that the y value, f of x, okay, f of x is y, approaches positive infinity. In the case of a negative leading coefficient, so doing a vertical reflection again, okay, we have something like this. Okay, as we go to the left and right, it's falling, so that's why we have down arrows. Okay, all 4 cases I capture in this little table. So you just have to determine n, which is your degree. So n is degree. So is your degree even or odd? And then an is your leading coefficient. Okay, so then for our sample function, that's been carrying through. So we found the zeros, behavior near them and between them in the last video. Same function, we're just going to describe its long-term behavior. So in this, I need to pick off the leading term. Boom, leading term, okay? I'm saying that n is 8, an is missing. Actually, it's just 1. It's positive, right? Okay, so in that case, I am in that up and up scenario. Okay, so I'm going to say in terms of arrow notation, its long-term behavior is given by an up as I go to the left and up as I go to the right. In terms of limit notation, what I need to say is that as x goes to negative infinity, as I go to the left, that's this first part, f of x is going towards infinity. I never want to say it's equal to infinity. Infinity is a concept, not a number. So that's 1/2 of the limit notation for this. The other half would be as I go to the right, what is happening to the y value? Well, that's also increasing. So there we go. Make sure you're fluent in both arrow and limit notation for working with polynomial functions or long-term behavior. So here we go. Make sure to get this table down in your notes. And now I think we're ready to just about assemble all the pieces of the puzzle to get a full graph of a polynomial function.